Hello everyone, today we'll continue learning Python and today I'll show you how to use WebSockets, what are WebSockets, and we'll make a Bitcoin graph with WebSockets. So let's start. But before we start that video, I recommend you subscribing to my Telegram channel. You will find lots of materials, modules, libraries, examples and tasks on Python in my Telegram channel. Also, I post all the announcements there, so if you want to understand what will happen to the channel in the near future, you can go here. And I respond to comments much faster than I do it on YouTube. So subscribe to my Telegram channel, link in the description down below. WebSockets and why do we need them? WebSocket is a technology that helps us to make our requests quicker. Why? Because every time we make an HTTP request, let's import the request library, the main library for HTTP in Python. If you haven't seen my video about requests and you don't know about them, then you should watch it. So for example, if I make request.get, get request, what I am doing right here, I open a connection, I get all the data I need, I send that data to the server validates the data, gives me the response, and then I close the connection. Well, server closes the connection, but it doesn't matter. So we open and close the connection. If I have 3 get requests, we'll open and close the connection 3 times. So we will make 6 additional steps. But if I need to get the data every second, so for example, while true, what I'm doing right here, I open and close connection millions of times. And why is that bad? Because that eats additional resources and additional time for our application. And because of that, what we can do is we can use WebSockets. So again, we use HTTP right here, and WebSockets as well use HTTP. But WebSockets only open and close connection once. However, HTTP opens and closes connection on every request. Again, WebSockets open and close connection only once, but HTTP opens and closes connections every second, or every request. There are some cons and pros to every method, but WebSockets are very popular nowadays. And as you can see, what I have right here, I have my URL or URI. So URL, it's unique resource location, but URI is unique resource identifier, but it doesn't matter, let's call it URL. Okay, URL for your convenience. So what I have right here, VSS, then we have that semicolon and double slash, stream binance.com, port 9443, stream, and so on. That's our URL, so that's our API. If you don't know about binance.com, it's a cryptocurrency exchange. I cannot use, for example, New York Stock Exchange today because it's Sunday and it does not work. I will not receive any data, but I can use cryptocurrency exchange. And because of that, I will do it. So as you can see what I'm doing right here, I get VSS. So what is VSS, first of all? You can see HTTP all over the internet. So HTTP, it's the protocol, but VS, just VS, it's WebSocket. So HTTP is HTTP protocol, but VS, it's WebSocket protocol. But when you see HTTPS, that means Hypertext Transfer Protocol secure or secured. But VSS, WebSockets secured. I think you understand what I mean. Then VSS double slash, so on, we have our endpoint, stream, and we get our streams. So again, it's just a Binance API. And as every API, we have some specifications, we have documentation, and you can go down in the description to go to the Binance official documentation. And if you want to develop or to improve in that area, in Binance, for example, API, in stock or crypto markets, then you can read that API, you can use it, and so on. But what I'm doing right here, I get stream, and I get only one stream. I get Ethereum, Bitcoin, but let's get Bitcoin. So BTC stands for Bitcoin. It's Bitcoin ticker, BTC USD T. So Bitcoin versus dollar, US dollar. Then we get our mini ticker. So again, it's just an API, and you can make your own API with WebSockets, but Binance uses that API. So with that URL or URI, we get our Bitcoin's price for the specific point in time. And that's just it. Yeah. So how we can use WebSockets to get our BTC USD price? If I just import requests, as I always do it, requests and then requests dot get, let's print it. What we'll see if I put URL right here. Let's call it, and as you can see, invalid schema. No connection adapters were found for our URL. Why? Because requests, let's go to request itself, it says requests HTTP library. There is no requests WebSocket library. As you can see, HTTPS before python.org. But we use WebSockets. Again, WebSockets secure if we add VSS as a protocol. We use WebSockets. And what we need to do? We need to install an additional library. Let's go to our terminal and let's install pip install WebSockets. So again, there are lots of libraries for HTTP, for WebSockets, and I'll use WebSockets plural WebSockets because there is library WebSocket in Python, but I'll use WebSockets. That's an asynchronous library for WebSockets in Python. Let's import it, and if you wish, you can use another library, but I'll use WebSockets. And what I need to do right here, again, it's an asynchronous library, and because of that, I need to import async.io. If you haven't seen my async.io introduction, then you should watch it on my channel. So async.io, and then if name equals main, that again means that our Python file is run directly, not imported. So if I'll go to settings.py file, for example, and I'll import main, our name variable will not be equal to main, because it is only equal to main when we run our Python file directly with Python, like with python.exe, and then pass to our file. Okay, then what I need to do right here, let's get our event loop. So loop equals async.io dot get event loop, then loop dot run until complete, and let's put main function right here. And we need to create that asynchronous main function. So async.def main, and let's put our URL inside of it, like that. Okay, so now we have our main function, and let's print URL to make sure that everything works. Let's print it. As you can see, we have our URL right here. Okay, what we need to do now? Now we need to use asynchronous context manager. So async with WebSockets.connect. Connect to URL as client semicolon pass. So what I'm doing right here, I create async.def main, I run it in my if name equals main clause, and then I use asynchronous context manager. So you have probably seen synchronous context manager, like just with, for example, with open file as file. But asynchronous context manager works with asynchronous functions, and actually that's it. It's just an asynchronous context manager. And if you want me to make a video on asynchronous context managers, then you should write that down in the comments. So async with WebSockets.connect to our URL as client. What we need to do right here, let's print client.receive, like that. Let's run it, and what we will have, enable trace-malloc, because we need to await. Again, it's an asynchronous library, and we need to await client.receive because it's a coroutine. Let's run it, and as you can see, we receive our JSON data. So again, with WebSockets library, we can use client.send, which is again a coroutine, and we can send, for example, hello.encode, as I did it in just sockets, because we sent bytes. But there are also libraries, and if you want me to make a tutorial, not just an overview of WebSockets as a technology, as I'm doing it right now, if you want me to make a tutorial on WebSockets library, then again, you should write it down in the comments. So you can send and receive information. But since we are only using that URL to get the information about the price, we will use await client.receive. And what we have right here, stream. Stream is just for information because we can have multiple streams, because as you can see, streams is plural, and we can provide many streams inside of that URL, but I will only use once, and then we only use one, and then we use data. So data shows the data we need. If you don't know about financial stock markets or crypto markets, then I'll explain everything to you. So E is just an event, it's for Binance, there is nothing with cryptocurrency. Then we have E capitalized. So E capitalized, it's our Unix time. So it's the time of the event, 24-hour minute ticker, of the event of our request await client receive. Then we have S. S, it's just our symbol, so BTC USDT. We provided it right here. Then we have C, which is close price. So imagine that you have a time span of 1 minute from the start of the minute to the end of that minute. You have close and open price. Open price, it's the price at the start of the minute. O stands for open. So that's the price at the beginning of that specific minute. And as you can see, it's $48,000. Then we have C, close. So that's the price for the end of the minute, which is $50,000. So our Bitcoin currency, our Bitcoin against US dollar started with $48,000 at the beginning of the minute and ended with $50,000. Then we have high, low, volume and quantity, but I will not talk about them because today we only need to make a graph, Bitcoin graph with WebSockets. But if you want me to make another video or a series of videos on financial markets, on crypto markets, then again ask that in the comments down below. And as you can see, we don't need that stream information, and because of that, what I can do, I can use JSON dumps, because again, that's the JSON data. And as you can see, we have okay, I don't have any unique values for JavaScript like null or undefined, but that's a string. We need to make a Python object out of the string, and because of that, let's use JSON.loads like that. So JSON.loads converts our JSON string into Python object. And again, you can watch my video about JSON, and let's print data right now. So nothing will change. Yeah, as you can see, stream BTC, but as you can see, now we have these things. We used to have double quotes, but now we only have one quote on each side. I think you know what I mean. That means that we have successfully transferred our JSON object into Python dictionary, or our JSON string into Python dictionary. So we get or we receive JSON string and we translate it to Python object using JSON loads. And again, we don't need stream, and because of that, I want to make data, so we'll just only use data, and now let's print it. And as you can see, we have a little delay before we can receive our data. We don't have that in requests, and why? Because we need to open our connection. We open our connection and then we close it, but that process takes a little more time, but it doesn't matter because we only do it once. If we need to make 1 million requests, we'll spend 2 seconds on connection open and close process. But if we need to make 1 million HTTP requests, we'll spend minutes or even hours on our connections. So what we have right here, again, E event type, E capitalized, it's the time. We need the time, so let's get E, and then we need data from C, so data close. We'll use close value of our Bitcoin to represent our graph. Let's print now, and yeah, as you can see, everything works fine. So what I need to do with data E, because it does not tell me anything with that number, because it's Unix time. Unix time is represented in a single number, in our case, that big number. And what I need to do, I need to import time library in Python. So I imported time module, and now what I need to do, I need to use a function, which is time.local time, and that function translates seconds into time struct. So time struct, it's a structure in Python time library that helps us to represent our date or time for our user. And it will be much more convenient for us. So I will show you and you'll understand everything. But I will not call it time because, as you can see, the module itself is called time. So let's call it event time. And let's print event time after that. But if I run my code right now, I'll receive an error. Why? Because data E, we receive data E in nanoseconds or in nanoseconds, and What we need to do because of that is translate these nanoseconds to normal seconds. So we need to divide, and when you put two division signs in Python, that means that you need to receive an integer at the end. But if you put only one, then we'll have some values after the dot. So for example, 2.5 or 3.2, but I need to receive just integer, so let's put double or no, double division as our sign, and then I will divide it by 1000. So now let's run our code and we will see what we'll see. We'll see time struct or struct time. So what is that? As you can see, we receive our time, and now we can see that the year is 2021, month is the third month, day is 7th, 20 hours, 55 minutes, and so on. What I need to do with that, or what I can do, because that is still not convenient at all. What I can do is use event time, then I need to put Python f string so I can insert values inside of that string. I think everybody knows about f strings in Python, but quickly I insert values inside of these curly brackets, and that's it. So let's put event time.tm hour, for example. I will not put any year, month, or day. I'll just put hour, event time dot tm second, or tm minute, first of all, tm minute, and then event time dot tm second, like that. So now if we run our code again, what we will see? We will see that. So as you can see, now we have a time, and then we have the value of the Bitcoin, so the value which we received in data C. And yeah, that's actually very great. And what I can do in addition is put while true right here. And what we do right now we only open the connection once. So we open it right here, and we'll close it right here. Not on print, but when we go right here on the 17th line. That's much better, because now we, as you can see, we receive data very quickly. Why? Because we only open the connection once. And yeah, that's actually great. So as you can see, our Bitcoin value is changing constantly, and yeah, now let's make our graph. So let's create function called, let's call it update graph. I'll show you how to make graphs with matplotlib library today. So let's install that library, pip install matplotlib. I have already installed it, so it will say requirements already satisfied. And let's close that terminal. So you need to install matplotlib library, and then what you need to do is you need to import matplotlib.pyplot splot. Matplotlib is pretty big library, so I will not tell everything about that library today. So I have that code that helps us to create a dynamic graph. I'll explain it in a minute, but now let's copy that and let's put it inside of update graph. So again, matplotlib library is a pretty big one, and our goal today is to just get familiar with WebSockets, and I think you are already familiar, but what I want to do, I want to create a graph because it's a great addition to that video. And what are we doing right here? We import matplotlib pyplot sub-library as PLT. So that's the most common import statement, like we do import numpy as np, so every programmer understands that np stands for numpy, and you don't need to write the whole name. Okay. And matplotlib is imported as PLT. And then what we do right here, we create our figure. So we create the whole plot, but then we need to create subplots. So ax equals fig, our figure, add subplot. And 111 means that we add it in the left upper corner. If, for example, I put 211, that means that we change the position of the... Okay, we just add one plot, and it doesn't matter actually in that situation. What we do next? We show our figure, so we show our graph. And in update graph function, which we'll call in our main asynchronous function, and by the way, as you can see, it's not asynchronous because we don't need update graph to be asynchronous. Yeah. So what we do right here, our subplot is named ax. So ax.plot. Plot, it's the function that makes plot line, so just a straight line, not straight line, but line, and we have x and y dimensions inside of that. Then we add x data and y data. and color is B, which stands for blue, but we can call green, red, and so on. So as you can see, G stands for green. That's my favorite color, and because of that I will call green. Okay, so again, plot makes plot line. Just a plot line. You understand what does it mean. And then what we do right here, we provide X data for X dimension and Y data for Y dimension. And let's create this list. So X data, Y data equals to a list. Now what we do right here, AX legend, it's just the legend of our graph. And what I'm doing right here, I provide a list because there can be many legends in our graph of a string, because every legend should be a string, obviously, a string of Y data minus 1. Y data will contain the value of the Bitcoin. And if we provide str, because we need again to put only strings inside of a legend, str of Y data minus 1, we get the last value, and our legend of the graph is the last value of our Bitcoin. I think you know what I mean. What we can do is put, for example, f last price and put Y data right here, like that, and remove additional parentheses. So now I provide the list because there can be many legends inside of one graph, and I provide last price as Y data minus 1. So minus 1 index gets the last value of our list. Then we draw that figure and we pause our plot for 0.05 seconds, but let's pause it for 0.1 second. And we do that to make sure that everything is rendered correctly and we have time to... so our application will not pause forever. I think you know what I mean. If in Windows you constantly update the application you're working into, then Windows decides that that application is paused forever. So I forgot the word, but I think you know what I mean. But if we put plt.pause, everything is alright. So we just need to pause to make sure that everything is rendered and everything is correct. Okay, then what we do right here, we connect to socket, we use while true to get the data constantly, then we get the data, we only get like the data we need, then we get the local time, we translate that local time inside of a string, and then what I should do, I should put update graph right here, but before that I need to put some data inside of X data and Y data lists. So let's do that, X data. So X is the time of our graph. So I think you've seen, for example, dollar graph or Bitcoin graph, X is always the time. So we need to put append from event time. And when we use Y data, we need to put data from C. So data from close, data from the price. Again, I just add the data and I update my graph. Now let's run our project, but before that I need to switch my screens in OBS. Let's run our project now, and as you can see we have our figure, and as you can see everything works fine. So yeah, that's our code, but not everything is not working fine because we have a lot of digits in our value. So as you can see, last price is $50,000. And that's right, because Bitcoin now is $50,000, as you can see right here. Let's pause that and let's go to last price. So let's change that and let's change Y data append. We will change it to float. Why? Because we have so many digits after the dot, and so for example 0, 6, 0, 0, 0, 0, 0, and our graph, and we cannot see like the whole number, we only see these digits because of the size of our window, of the graph window. So let's run it again, and as you can see now everything works fine. So we have 4, oh no, not everything is not working fine. What is that? 7, 0, 50,000. That's very strange actually. 50, oh no, everything is right. I think that's just the render problems. So as you can see now everything is right, but our graph is kind of strange. Okay, what I need to do is use integer from float, and I think it will remove all the strange things in our graph. So let's run it again, and 4, just 4, 50,000. Okay, I think that's just a render problem and our code cannot render the whole number. I don't actually know. But as you can see now, everything works fine. So now what we do right now, we get our values. That's just our Bitcoin graph. But again, I think that something is not alright. What is that? I don't know really. Last price is correct because as you can see, we get 50,000 and we have $50,000 right here. By the way, we can put dollar after that, dollars, and let's run it again. Let's run again. By the way, as you can see, color is G right now, and our pot is green. So yeah, I think that that's just the render problem with. No, why is that happening? That's kind of strange actually. 4. Let's go right here and let's print our integer from float. I really want to know what is happening. Why we get the wrong values at first. So let's put that and let's run our code again. I want to see. No, everything is alright. Yeah, I think that's just the render problem. So now everything is alright. I checked that because we get the right value in float. And yeah, that's just our Bitcoin graph. So as you can see, now we get the data constantly and we only make one open and close procedure. That's much better because now we get the data very quickly and we spend not a lot of time on connection. On connection opening and close procedures. So yeah, now everything's alright. But our graph is a bit strange. I think that's because of the integer we get because no, I really don't know. It seems kind of strange to me because the video I made for my Russian channel had much more relevant graph. But yeah, as you can see, values are right. That means that everything is alright with graph. But there is one drawback: is we have these merged values, and I will not solve that because it has nothing to do with financial APIs or WebSockets or Bitcoin. It's up to you to solve that problem. And you can look up my code in my GitHub. So yeah, that's actually it. But no, now as you can see, our graph is much more relevant. So yeah, now we have our Bitcoin graph. I'm talking too much. Thank you for watching and good luck.